Hello everyone, my name is Chinmay. I'm currently pursuing my 8th semester in Vivekananda Institute of Technology in the domain Information Science and Engineering, and I'm currently working as an intern in 3QI2606 in the domain Data Center and Engineering. Thank you. I'll be explaining about a new topic, ISP network design using Cisco Packet Tracer. We'll be using 10 router network with distributed services, and let me explain about the ISP network. An internet service provider network connects multiple local networks and provides internet connectivity to users. The continuous connectivity ISP network ensures that users from different locations can communicate through a centralized backbone network. The network availability. A well-designed ISP network minimizes the downtime and ensures reliable connectivity. The network backbone. The central router acts as an ISP backbone connecting multiple branches network. The communication flow. Data travels from local LAN networks to branch to routers to core ISP router and the destination network. The project initiation and proposal. The project background. Modern organizations require continuous internet connectivity across multiple departments and locations. ISP network provides centralized communication infrastructure connecting multiple LAN networks. The problem statement. Network isolation. Separate LAN networks cannot communicate without routing. Single network limitation. Without an ISP architecture, networks remain isolated. Scalability issues. Expanding network without proper architecture leads to congestion. Our main project goals are connect multiple LAN networks using a central ISP router, provide the communication between all branch networks, design a scalable network topology, enable reliable packet routing between LANs. The project goals and scopes are the main project objectives are implement a 10 router network architecture, design a core transit cloud, connect 6 edge branch networks, implement EIGRP dynamic routing, enable IP relay services, ensure efficient traffic routing, and the devices used are core router, ISP router, branch routers, Cisco 2960 switches, PCs and laptops, Ethernet connections. As you can see at the center you have 3 routers connected by another router, and that router has an 2 switches, that is 2960 switches, and at the last it is end devices, that are 4 end devices, and 2 laptops that are connected to switches. And the routers use a 1941 routers in Cisco Packet Tracer. Let me come across network planning and topology. Core ISP router. Central router that connects all branch networks. Branch routers. Each branch router connects its LAN network to the ISP backbone. Access switches. Switches connect end devices such as PCs and laptops. LAN network. Each branch contains its own subnet network. As you can see in the diagram, you can see at the centralized there are 4 routers, that is router 1, router 2, router 3, router 4, that acts as a cloud in a single domain, in a middle domain. And the outer part there are 6 routers, that is R1, R2, R3, R4, R5, R6, and that router is connected to LAN. It can contains 2 switches and end devices. Here comes the connectivity and the traffic flow of the diagram. PCs, end devices used by users to send and receive the data. Switches provide internal communication within each LAN. All the end devices are connected to switches, and these switches are connected to the router. As you can see in the diagram, the PC in LAN 1 are connected to switches, and that switches are connected to ISP router, and same with the other side. And the router forward packets between different networks. If one end device wants to communicate with another end devices in a different LAN, the router play an important role by sending the packets from one LAN to another LAN. The core ISP router, it acts as a backbone that connects all the branch network. The primary communication path are from PC to switches, switches to branch router to core ISP router, to destination router and the destination PC. Here comes the routing protocol. We'll be using the EIGRP routing. The network uses Enhanced Interior Gateway Routing Protocol. It is EIGRP. It is a full form of it. Some of the features of EIGRP are their fast convergence, efficient route calculation, loop-free topology, supports VLSM and CIDR. EIGRP ensures efficient routing between all the routers. And the router configuration example you can see over the interface configuration, interface serial 0/0/0 and its IP address are as follows: 192.168.1.1 and the subnet mask is 255.255.255.252 and no shutdown. All the systems will be shut up and unshut so that the traffic can be flow easily. If there is any kind of shutdown, please make sure that will be unshut or no shutdown. And the network implementation steps are: step 1, create 4 router core cloud, and step 2, connect 6 edge routers, step 3, configure IP addressing, and step 4, enable EIGRP routing, step 5, verify the connectivity just like pinging and all the EIGRP, does it have any protocols or not, you can check it. And the challenges faced while doing the projects are: large trend router topology configuration, EIGRP neighbor establishment is very important. You can also check for after establishment, you can check whether they are connected or not by show EIGRP neighbor. Correct IP addressing is very important while assigning the IP address for every router, switches, and PCs. The troubleshooting routing issues may occur. Please make sure you troubleshoot them and solve them. The results of this are: the network successfully achieved, EIGRP convergence will happen, router to router communication takes place from one LAN to another LAN. With the help of router, they can communicate and they have end-to-end connectivity, efficient packet forwarding without any packet loss, and 0% packet loss will happen. Let me come to the conclusion. The project successfully implemented a 10 router distributed network using EIGRP. The architecture ensures scalability, reliable communication, and efficient routing. Hello everyone, welcome back. I'm going to explain about the project. Here you can see this is my basic structure and design. You can go through it. And there are 3 routers in the middle, which are everything is connected to the serial port. And you can see which port is connected to which port, and we can SC is a serial number. Serial number 0/1/0 is connected to 0/1/1. And like this, we are connecting the center out 3 routers to by using the serial port. We are using the connection, and from the router to another router, we'll be using Giga Ethernet port. We can see over here GigaNet 0/0 to GigaNet 0/1. And for every router, we'll be assigning the IP addresses, and each PC will be having an IP addresses. As you can see, every router is connected to another router with having 2 switches, and each switches will be connected to 2 PCs. And you can see there are too many of IP addresses assigned by everything. And these are the structures, you can go through it. And you can see my network ID, I'll be mentioned there in the broadcast ID also. And you can see there are different LANs, and you can see the EIGRP troubleshooting commands which I have used. These are show IP EIGRP neighbors. This helps to know which router is connected to their neighbor's router. We'll get to know by using this command. You can type this command in the CLI page. I'll show you that. Go to router, go to CLI, and you can type it over here. You'll get to know like how many neighbors are connected to which topology, and show IP EIGRP to topology. You'll get to know what type of topology it is connected to. And for show IP route EIGRP, you can know what and all the routing is happening between the routers. And for the running configuration, the show running configuration will help you know what and all configurations you did in the PC switches or the routers. By using the term show running config in a particular router or switch or PC, you'll get to know what and all configurations you have done. And by using that configuration, you can add or remove some configuration which will help you in it. And for the show IP protocols, you'll get to know what and all the IP addresses you have mentioned. These are some of the troubleshooting commands. By using this, you can get to know any kind of errors or any kind of configurations you have made. I'm going to show you the output, how it should come. This routing EIGRP will be used for pinging one monitor to another monitor by using the different lanes. I'll show you. For example, this is a one PC. I'll be pinging this PC to other PC. Go to this PC. Go to command prompt. I'll use ping 192.168.6.5 and enter. And you can see the pinging is happening with multiple PCs. Again, you see replies coming from that PC. By the packets are being transferred, you can see packet sent are 4 and received are 4, and the lost package is 0. But you can see the round trip is milliseconds, and minimum is 11 meter per second, and maximum is 55 meter second, and average is 28 ms. These are the pinging outcomes, and I'll show you from the another PC also. By using this, you can get like any kind of operations you have done is going, or the message is transferring in a correct manner. Ping 192.168.1.4, and you can see it is pinging from the same LAN network, and the output will be coming like this. You can check this out, and you can, for a quick result, you can go for the menu tab, message tab. From one PC to another PC, you can select, and you'll get a quick response over here in a toggle list, and you can see it is a successful. And after this, go to, for the configuration, go on particular router, switch, or anything, then go for any CLI command. You can type your configurations. You should turn on the router, or you should turn on the PCs before any kind of any configurations. This is the basic structure of the network design topology. I'm going to explain about the report now. This is the report which I have created, and I'll explain about the report. These are the project plan sheet. You can see the network establishment, IP addressing scheme, IP management, and VLAN, inter VLAN setup. This will be the phase 1, and you can get to know what and all I have done in this. For the phase 1, you have done with the project initiation and proposal, be knowing what project we are doing, how many routers we are required, and what kind of management route will be using. Everything will be mentioned in the project initiation and proposal. For the project planning, we'll be using the router 1941 routers, and with the switch it will be 2960 switches, and for all the PSAs it will be connecting with all the IP addresses in particular LAN. You'll get to know about the IP addressing scheme also, and what type of subject mask, what type of IP address will be using. I've mentioned that. And this is nothing but the project execution and implementation. We'll be executing the project in this, like configuration, what and all will be done over here. And for implementation also, you can refer my report. You'll get to know any kind of doubts. You can reach out to my description or comment box. And this is a layer 3 gateway relay implementation. You can get to know by reading this. And this is a dynamic routing convergence. And monitoring and controlling will be the troubleshooting commands, which I've shown told you before. You can read it out, and you can check this out. And these are the project closing, and the output should be the pinging from one PC to another PC, and you can get to know like is it working or not. And you can go through this report, and I'll explain about the Scrum board. And this is a Scrum board, and these are the 5 phases which have started: phase, project initiation and proposal, project planning, and the project execution, monitoring and controlling, and project closing. These are some phases, 5 phases, and these are the dates which I mentioned below. And you can refer to this, and you can go check through mine, and I'll show you the dashboard.